Hey Shanez, I thought I would just put together a quick video for you here to explain this scatter plot. So months employed on the horizontal axis and then age on the vertical axis. So let's see. Let's see. Let's start by getting the data that we need here. So there's months employed and then age. In order to get the data that you want for age without getting everything else in there, hold down the control key and you can get that data without getting everything else in between it. There we go. And then once I have the data highlighted, let's go to insert. And right here in the middle of this charts option is a scatter plot. And there's the data, the bivariate data. So that's months employed on the horizontal axis and the corresponding age on the vertical axis. So those are all ordered pairs. And then let's see, the correlation coefficient that would go along with this, there's a number of different ways you can do this. Let's see, I'll just show you here very quickly. Let me pull this up to the top so we can, actually, let me just see if I can cut it and bring it all the way up to the top here. Yep. So an easy built-in feature in Excel is equals CORREL, correlation. And then all I have to do is scroll in the data separately. So again, months employed would be the first array, and that's what we have on the horizontal axis, and then a comma, and then I can go get age as the what effectively looks like the y variable here. If you think back to your old algebra days, and if you close that up, and then you get a value of about 0.31. And what that measures is, remember, the correlation coefficient is a value that varies between -1 and +1. And a set of data that has a correlation coefficient of 0 would say that there is no linear correlation. And again, we're measuring the strength of the relationship here by a straight line. And I'll show you that straight line here in just a minute, but let me try to explain this 0.31. So if the value was -1, what you would see is you would see a line that falls as you look at the data in the what really looks like the first quadrant. All the data would lie on a straight line, and the line would fall in the in the first quadrant from left to right. If it was +1, it would be all the data would lie on a straight line that rises from left to right, just like the old algebra days. So a correlation coefficient of about 0.31 says, yeah, there's a it's an okay relationship. 0.3 is not bad, but obviously, as you go from 0 to 1, the closer you get to 1, the more perfectly correlated the data is. So 0.31 just says that the line of best fit rises from left to right as you look at the data in the plane. And I can show that to you here very quickly. If I just put my cursor on any one of the data points and right click, I can add a trend line. And this linear trend line, let's see, actually, I don't need to actually say anymore. So that actually is the line of best fit. And again, there's some more discussion that comes with this when we talk about regression analysis in a couple weeks. But there is the line, and basically what we're saying is that the slope of this line effectively is it's not 0.31. Actually, let me go back and show you what the slope of this line is. Add a trend line and display the linear equation on the chart. And what you get when you do this is the equation of this line, given the data, is 0.105x plus 31.07. So actually the slope of this line is 0.105. What the correlation coefficient is measuring is how strong overall is the linear relationship between months employed and age. So that's kind of the takeaway that I'm looking for on this for this week, and then we'll talk more about it in let's see, when we get to regression here in a couple weeks. So I hope that's helpful. If not, please follow up with me. Thanks and have a good night.